So the next thing we're going to do is basically the exact same thing we did before on joint A, but with joint C. And so let's go ahead and start by drawing a free body diagram, or redrawing our free body diagram at joint C, with of course CD, which is going down and to the right. And then we've got an upward force going up, that is 240 pounds, pushing up. And then we've got a leftward force, BC, on joint C as well. And just like before, we're going to redraw vector CD. I need to scroll down so I have a little bit more room. But we're going to go ahead and redraw this free body diagram by redrawing our vector CD. And let me make sure I have the right color selected. We redraw CD for ourselves. And we'll label it CD. And go ahead and add its arrows. And then we can go ahead and replace CD with its X and Y components. So we'll go ahead and add a CDX and a CDY. Make sure I get the right color here. CDY, or our Y component of vector CD. And so the next thing we're going to do is redraw our free body diagram for joint C. And we'll go ahead and say, well, we still got 240 pounds going up, right? And we still got BC going to the left. But instead of drawing CD down and to the left, we'll go ahead and draw CDY going down. And we'll draw CDX going to the right. So we'll do the same thing as before. We'll just say, well, the sum of all forces in the X direction is equal to 0. And there's only two things there. We got BC, we'll say equals BC plus CDX. So make sure I get the right color again. Plus CDX, or our X component of CD. And I recognize that CDX is going to the right and BC is going to the left. So I can just set my leftward forces equal to my rightward forces. I'll say BC equals CDX. But you'll notice we don't have enough information to solve for either one of these. But we can very easily by using the sum of all forces in the Y direction and this sort of vector triangle that we created. So we'll say sum of all forces in the Y direction is equal to 0. And then we'll look, well, what are our sum of all forces in the Y direction? We only got 2. We've got 240 pounds, which is going upward. And then we've got CDY, so we'll say, I'm going to make sure I get the right color, plus CDY, which is going downward. And if these two forces add up to 0, that means they have to cancel each other out. In other words, I can rewrite CDY equal to our upward force, which is 240 pounds going downward. And so I can rewrite that over here. And then I can turn this into a triangle by using our tip-to-tip method. I will redraw vector, or not vector, our X component of vector CD down here. And I will remember that we solved for the angle earlier, which was 45 degrees. And so to solve for CDX, we just got to look and see, well, what version of our triangle are we using? What parts of our triangle are we using? Well, we know our opposite, and we are looking for our adjacent, so that would obviously be tangent. And I could use the sine for solving for CD and then use cosine for CDX if we wanted to for the record, but I'm going to go ahead and go this way. We use tangent of our angle, which this time is 45 degrees. And some of you might have noticed, well, if it's a 45-degree triangle, there's a trick you could do here, and you could, but I'm going to go ahead and use our regular math to solve for it. Also, CDX equals opposite over adjacent. Well, the opposite is still 240. And we're going to divide that by our adjacent, which we don't know yet. That's kind of the point here. And that is CDX. And then I'll put this over 1 so I can make this proportion problem. We'll say, well, 1 times 240 divided by the tangent of 45. So we pull out our handy dandy calculator. And we can just say, well, 240 divided by the tangent of 45. And what do we get? Well, we get 240. And that might have been the trick that you recognized earlier. Make sure I get the right color again. We recognize that if it's a 45-degree triangle, that means our X and Y components are equal to each other. Just a little trick you can remember if you want. But this equals 240 pounds. So if CDX equals 240, that means BC also equals, well, actually, I'll go ahead and write it over here. That means BC also equals 240 pounds. Go ahead and make sure I write this out correctly. Equals 240 pounds. And so that's one of our vector forces, and then we have everything we need to solve for vector CD, and there's several ways we can do it. But I'm going to go ahead and use Pythagorean theorem, because if you think about it, it works. So we say vector CD is equal to the square root of our x and y components. So we'll say 240 squared plus, well, of course, 240 squared. And then we pull out our handy dandy calculator and we'll say, okay, what is the square root of 240 squared? Make sure we write it correctly. 240 squared plus 240 squared. And you might have noticed, again, that we could use our triangle tricks to solve for this as well. Or we could have just done sine or even cosine to solve for this, but I'm just going to go ahead and use this trick again. And what do we get? We get 339.4. So I'll just call that CD is equal to 300. Let me make sure again, that's 339. Yeah, I want to make sure I don't write down the wrong number here. 339 pounds. And that's all the members acting on joint C.